In this session, let's look at infimum and supremum of a sequence through an example. So we have sine n times pi by 2, a sequence. The terms are sine of 1 times pi by 2, sine 2 times pi by 2, sine times 3 pi by 2, and so on. Simplifying it, we get a sub n is equal to sine pi by 2, sine pi, sine 3 pi by 2, and so on. And evaluating these terms, we get a sub n is equal to 1, 0, minus 1, 0, 1, and so on. Now, the sequence is bounded above by 1 and below by minus 1. Since it is bounded above as well as bounded below, we just say it is bounded. Formally, if there exists m, m in real numbers such that m is less than or equal to a sub n, which is in turn less than or equal to m for all n in the set of natural numbers, then we say that the sequence is bounded. Always remember, the upper and lower bounds might appear anywhere in the sequence or may not appear in the sequence. The infimum of a sequence is the greatest lower bound of the sequence. So, a real number b is the infimum of a sequence if b is a lower bound of the sequence such that b is less than or equal to a sub n for all n. That means b is less than or equal to all the terms. And if b is greater than or equal to c for every other lower bound c. So let's look at an example and understand this. So we have a sub n is equal to 1 by n. Now here 0 is a lower bound and a sub n is greater than 0 for all n. Since all the numbers less than 0 are also lower bounds, 0 is the greatest lower bound. So it is called the infimum of the sequence. So infimum of a sub n is equal to 0. And here in this example, infimum of a sub n is not in the sequence. Since as n goes to infinity, 1 by n goes to 0, but it actually never reaches 0. So that was infimum. Now let's look at supremum. The supremum of a sequence is the smallest upper bound of the sequence. So a real number b is the supremum of a sequence if b is an upper bound of the sequence, that is b is greater than or equal to a sub n for all n, and if b is less than or equal to c for every other upper bound c. So again, let's look at an example. We have the sequence minus 1 by 2 to the power of n is equal to minus 1 by 2, comma 1 by 4, comma minus 1 by 8, comma 1 by 16, comma minus 1 by 32, and so on. Infimum is what? It is minus 1 by 2. Just try to confirm this. Minus 1 by 2 is equal to minus 1 by 2. So, okay. 1 by 4 is greater than minus 1 by 2. Minus 1 by 8 is greater than minus 1 by 2. And so on. So, here, what is supremum? Supremum of minus 1 by 2 to the power of n is equal to 1 by 4. Since a sub n is less than or equal to 1 by 4 for all n. So let's again confirm this. Minus 1 by 2 is less than 1 by 4. 1 by 4 is equal to 1 by 4. Minus 1 by 8 is less than 1 by 4. 1 by 16 is less than 1 by 4. And so on. Now let's look at some interesting examples. So here we have A sub n plus 1 is equal to 1 by 2 times A sub n plus 2 by A sub n, where n is in the natural numbers and we can choose A1. We can choose any positive number. So let A1 is equal to 1. So we choose the simplest option. A sub 1 is equal to 1. Then what will be A sub 2? It will be 1 by 2 times 2 plus 2 by 2. So 2 by 2 is 1, 2 plus 1 is 3, 3 by 2 is 1.5. So we have A sub 2 is equal to 1.5. Similarly, if we keep on identifying the next term, we get A sub 3 is equal to 1.41666667. A sub 4 is 1.41425157. A5 is 1.41421356. A sub 10 is equal to 1.4142135662. Do you realize what is happening here? It is getting closer and closer to the square root of 2. Just to confirm it, let's bring in the root 2. So here you notice 1.5, 1.41, 66667, 1.4142, 1.4142, 356, and so on. So the terms of the sequence are approaching root 2 as n goes to infinity. Here, A sub 1, since we can choose the first term, if we choose a number between 0 and root 2, our infimum of this sequence will be A sub 1 and supremum will be root 2. If A sub 1 we choose something greater than root 2, say for example we choose 2 or 3 or 4, then infimum of A sub n is equal to root 2 and supremum of A sub n is equal to A1. If A1 we choose as 0, then we end up with division by 0. So that's not a valid choice. Now, if A sub 1 is less than 0, so instead of choosing 1, if we had chosen minus 1 or minus 2, then it converges to minus root 2 instead of root 2. Okay, now let's look at another example. Let's say we have a sequence 1, 1 by 2, minus 1 by 8, 1 by 16, minus 5 by 128, and so on. Then its formula is basically a little bit complicated. A sub n is equal to minus 1 to the power of n minus 2 times 2n minus 5 double factorial divided by 2 to the power of n minus 1 times n minus 1 factorial. Here, n is greater than or equal to 2 since A sub 1 is chosen. So A1 is chosen and this formula generates the rest of it. So here 2n minus 5 double factorial basically means taking the factorial of odd numbers. So here for the first term, second term, we will have 2 times 2 minus 5. That is 4 minus 5. That is minus 1 double factorial. But minus 1 double factorial is treated as 1. And next term onwards, it becomes straightforward because now n will be 3. 3 to 6 minus 5 is 1. So 1 double factorial. So here the series associated with this sequence tends to root 2. So if we sum up, the partial fractions that we get will approach root 2. So S sub 1 is equal to 1. Pretty straightforward. S sub 2 is equal to 1.5. 1 plus 1 by 2 is 1.5. S3 is equal to 1 plus 1 by 2 minus 1 by 8. That is 1.375. And so on. So again, you will notice that it is approaching 1.41421356 root 2. So in the previous example, we saw that the terms approach root 2. Here the difference is the partial sums approach root 2. And here in this sequence, infimum of a sub n is equal to minus 1 by 8 and supremum of a sub n is equal to 1. Actually, a sub n, whatever we choose as the first term, will be the supremum. And the partial series oscillates around root 2 while converging. So here, let's see, 1, it is less than root 2. 1.5, it is greater than root 2. 1.375, it is less than, greater than, less than, greater than, less than, and so on. It will keep oscillating around root 2 and slowly converge. So that was infimum and supremum of a sequence. Now, if you found this session helpful, please do like, share, and subscribe. Comments, suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.